Welcome back to the class. Dear children, today we are going to learn about the chapter number 18, Observing Space and Telescope. The objective of the lesson are forms of light, telescope and its types, telescopes in the space and the Indian Space Research Organization. These all are the objective of the lesson. Let's begin the first one, forms of light. Dear children, before also we were studied about the light. Light is nothing but the electromagnetic radiation which causes sensation to the vision is said to be the light. Every wave has its own characteristic wavelength. We know that our eyes can see only the object which has the wavelength in the range of 400 nanometer to 800 nanometer. Such light is said to be the visible light. If any object emits the light in this range, then we can see the object. Above 800 nanometer, if any object emits the light, we cannot see such object. Or even if the object emits the light below 400 nanometer, that object also we cannot see with the help of our naked eyes. We know that 1 nanometer is equal to 10 raised to negative 9 meter and 1 picometer is equal to 10 raised to negative 12 meter. According to this, there are different types of radiations. Let's see one by one. First one is the radio waves. The wavelength of radio waves are longer than 20 centimeter. The wavelength of microwaves is in the range of 0.3 millimeter to 20 centimeter. Infrared waves, the wavelength of infrared waves is in the range of 800 nanometer to 0.3 millimeter. Dear children, the wavelength of visible light that we already studied is nothing but the 400 nanometer to 800 nanometer. Ultraviolet rays, 300 picometer to 400 nanometer is the wavelength of ultraviolet rays. The wavelength of X-rays is 3 picometer to 300 picometer. And the last one is the gamma rays. The wavelength of gamma rays is shorter than 3 picometer. This is all about the different wavelength of different radiations. Our eyes can see only the visible radiations. That's why we are free to use the visible radiation telescope. That is nothing but the optical telescope. Optical telescope is made from the regular lenses or mirrors to see the visible radiations coming from the heavenly objects present in the space. Dear children, many heavenly objects are present in the space. They are emitting the different types of radiations. If we are using only the optical telescope which work on the visible radiation, then we can see only the objects which emits the visible radiation, means in the range of 400 nanometer to 800 nanometer. If you like to observe, then we can use the optical telescope which work on the basis of visible radiation. Most of the optical telescope, the objective lenses are fitted. Objective lenses are responsible to collect the maximum amount of light coming from the heavenly objects. To collect the maximum light, the objective lens should be as large as possible. Second one is the eyepiece. Eyepiece is responsible to produce the large image of the source. Light rays changing their direction as they enter in the lens from the atmosphere and again when they entered in the atmosphere. So if the light is passing through the lenses, there will be the change in the direction of the light rays, which is said to be the refraction. That's why such telescopes which uses the lenses or the laws of refraction, such a telescope is said to be the refracting telescope. Refracting telescope have many difficulties. Let's see one by one. If we wish to obtain a bright image of our source by collecting the maximum possible light, then the objective lens must be made as large as possible. Dear children, to make the objective lens as large as possible, it is very difficult because the objective lens is very large. Large lenses are very heavy and tend to get distorted. This is the first problem in the refracting telescope. Second difficulty is that as the objective and the eyepiece are placed at the opposite ends of the telescope, the length of the telescope also increases with increase in the size of the lens and the telescope becomes difficult to manage. Third one, the images formed by the lenses have errors of colors. This is said to be the chromatic aberration. To overcome these all the difficulties, the telescopes are made from the concave mirrors because mirrors are acts as a reflecting surface. As the light rays get reflected by the mirrors, they are called reflecting telescopes. Mirrors as large as possible to make because of the small pieces of the mirrors are connected together to make the big objective lens or objective mirror. First thing. Second thing is that due to the reflection of light, there will be proper appearance of the images. The blur images can solve the problem of blur image will solve. The problem of the color of the image will also solve by using the mirrors. Mirrors are used in the reflecting surfaces or reflecting telescopes, and lenses are used in the refracting telescope. The reflecting telescopes are of two types, Newtonian Telescope and Cassegrain Telescope. Let's see the first one, Newtonian Telescope. Dear children, light rays coming from the space are reflected by the concave mirror. Before reflected rays converge at the focus, they are deflected again by the small plane mirror. As a result, they get focused at a point laying on the perpendicular to the axis of the telescope cylinder. They pass through the eyepiece and we get a magnified view of the source. Let's see the construction of the Cassegrain telescope. The student, Cassegrain telescope are also used a concave mirror. Here, light rays after reflection from the concave mirror are reflected back towards it by a small convex mirror. They pass through a hole at the center of the concave mirror and then pass through the eyepiece situated at the back of the mirror. The eyepiece gives us a magnified image of the source. This is all about the Cassegrain telescope. Let's see the radio telescope. Many heavenly objects emit radio waves in radiation. In addition to visible radiation, we cannot see this radiation with the help of our eyes. A special type of telescope is used to receive these rays. It is called as radio telescope. A large radio telescope called GMR nothing but giant meter wave radio telescope located at the Narayangaon near Pune. Radio telescope uses the radio waves having the wavelength of about 1 meter coming from the heavenly objects to study these rays. The telescope is actually a collection of 30 dishes, each having a diameter of 45 meter, which is spread in the area of 25 kilometer, in such a way that all 30 parabolic dishes of radio waves work as a single radio telescope. Radio telescope has been made by Indian scientists and engineers at minimum cost. It is a world standard research facility. Scientists study the solar system, solar winds, pulses, supernova, interstellar hydrogen clouds with the help of GMRT. Scientists from all over the world come to India to make the use of this facility. This is all about the radio telescope. Telescopes in the space. Visible light and radio waves emitted by heavenly objects present in the space can pass through the Earth's atmosphere and reach the Earth's surface. So, optical and radio telescopes can be erected on the surface of the Earth. These are the Earth-based telescopes, which creates many problems in making the good quality observations. Visible light coming from heavenly bodies has to pass through the Earth's atmosphere and to reach the Earth's surface. During this journey, some of the light is absorbed by the atmosphere and the intensity of the light reach the Earth's surface decreases. The second problem is caused by changes in the atmospheric temperature and the atmospheric pressure. To overcome these all problems, scientists concluded that we can keep the telescope on the mountainous region. At night, there is a two-city light that also create a problem to observe the heavenly objects in this space. And finally, scientists plan to send the telescope in this space. These problems do not exist in this space, and the image obtained by the space telescope would be bright, very clear, and will remain at one place. Scientists have turned this idea into reality. This is all about the telescope in space. Let's see the new topic, that is Indian Space Research Organization, located at Bangalore, commonly called ISRO, established in the year of 1969. The main aim of the ISRO is to develop the technology for making and launching artificial satellites. ISRO has successfully launched a large number of satellites in this space. ISRO's program is among the successful programs undertaken by independent India. Dear children, INSET and GSET series of satellites support our telecommunication network, television broadcasting and meteorological services. It is because of that telephone, television, internet services are available everywhere. The EduSat series satellite is used for the education. IRS satellite series is used for monitoring and management of natural resources as well as the disaster management. In 2015, Indian Space Research Organization launched artificial satellite called AstroSat. In space, this satellite has ultraviolet light as well as X-ray telescopes and detectors. Most of the part used in this telescope is made in India. This is all about the Indian Space Research Organization. I hope so it's clear to you. Thank you very much.